Introduction to networking. In this animation, we are going to see Introduction to networking. What is a network? A network is any collection of independent computers that communicate with one another over a shared medium. A computer network is a collection of two or more connected computers. When these computers are joined in a network, people can share files and peripherals such as modems, printers, and tape backup drives. The computers on a network may be linked through cables, telephone lines, radio waves, satellites, etc. Importance of computer networks. User can share data with high-speed internet connection. User can access server-centered database for better communication using internet services such as email, mailing list, and Internet Relay Chat, that is IRC. Sharing of devices such as printers and scanners. Sharing of files such as text, audio, video, images, etc. Sharing of programs or software such as online photo editor and format editor are some examples of sharing programs. Advantages of networking. Speed. Sharing and transferring files within networks are very rapid, thus saving time while maintaining the integrity of the file. Cost. Networkable versions are available at considerable savings. Shared programs on a network allows for easier upgrading of the program on one single file server, instead of upgrading individual workstations. Security. Sensitive files and programs on a network are password or designated as copy inhibit, so that you do not have to worry about illegal copying of programs. Flexible access. Access some files from computers throughout the firm. Resource sharing. Resources such as printers, fax machines, and modems can be shared. Disadvantages of networking. Network failure faults can cause loss of data. User work dependent upon the network. A hacker can easily access. Resources could be located too far from users. Local Area Network (LAN). In this animation, we are going to see Local Area Network (LAN). LAN is a group of computers and network communication devices within a limited geographical area such as home, school, and office building. In an office environment, several computers are connected through LAN, which allows them to share files and data. The devices used in this network can be connected via wired cable or wireless links. Depending on the needs of an organization and the type of technology used, a LAN can be as simple as two PCs and a printer in someone's home office, or it can extend throughout a company and include audio and video peripherals. LANs are designed to allow resources to be shared between personal computers or workstations. The resources to be shared can include hardware, for example a printer, software, for example an application program, or data. The most common LAN topologies are bus, ring, and star. Early LANs had data rates in the range of 4 to 16 megabits per second, that is Mbps. Wireless LANs are the newest evolution in LAN technology. LANs are configured in any one of the two basic structures such as peer-to-peer, client-server. Connection establishment of LAN. Connect your router, that is hub or switch, with modem to access internet. All nodes are connected by cable or wirelessly to a central point, which is called a hub or switch. LAN applications. In this video, we are going to learn about LAN applications. The most widely used LAN applications are in the office environment. In an office environment, LANs are mainly used for three purposes: sharing, inter-office communication, internet communication. Sharing hardware, sharing software, sharing data. Sharing hardware. Users can be connected through local area network to the single printer or data storage. Jobs from each user are queued to that single printer. Sharing software. Through LAN connection, users can share programs such as accounting programs, which is stored on a single machine. Sharing data. Sharing large database between users is also another big advantage. Inter-office communication. The employee of a company can communicate with each other using this network. Some of the LAN messenger used within the office area are CD Messenger, Outlook Messenger, Tonic. These types of communication are sometimes more effective than voice communication by phone, where users can save money. Internet communication. Another usage of LAN in an office environment is external communication via the internet. Each employee can use the LAN for the connection of the internet. Host computer is connected to the modem or hub. Through hub, all the systems in the office get access to internet. Wide Area Network WAN. In this animation, we are going to see Wide Area Network WAN. Wide Area Network WAN spans over a large geographical area such as a state or a country. A wide area network is different from MAN because of the distance between each of the network. The best example of a WAN could be the Internet, that is the largest network in the world. The world's popular and longest wide area network is an Internet. WAN makes communication between computers and users in one location with the computers and users in another location. It covers long distance via telephone lines, fiber optic cables, or satellite links. WAN connection types. From the animation, we are going to see WAN connection types. The protocol used in a WAN is TCP/IP in combination with the devices such as modem, router, access server, channel service unit or data service unit, that is CSU or DSU, and WAN switches. The three different WAN connection types are dedicated connection, circuit switching, packet switching. Dedicated connection. Dedicated connection is also referred as point-to-point connection or leased connection. It uses synchronous serial lines up to 45 Mbps. No setup is made before transmission. It constantly transfers data. Circuit switching. The circuit switching connection is same like a phone call. No data can transfer before and end-to-end connection is established. It uses dial-up modems or ISDN, Integrated Services Digital Network. It is used for low bandwidth data transfer. Examples of circuit switched networks are dial-up, ISDN, Integrated Service Digital Network. Packet switching. In packet switching, messages are divided into packets before they are sent. The packet switching transfers packets across a carrier network. Each packet is then transmitted individually and can even follow different routes to its destination. Speed can range from 56 kbps to T3, that is 45 Mbps. Examples of packet switching are frame relay, Internet Protocol, Ethernet. Node. In this video, we are going to see about node. A node is a system or device connected to a computer network. Nodes can be computers, personal data assistants, that is PDAs, cell phones, or various other network appliances. For example, if a network connects a file server, 5 computers, and 2 printers, there are 8 nodes on the network. Each device on the network has a network address, such as a MAC address, which uniquely identifies each device. This helps keep track of where data is being transferred to and from on the network. Host. In this video, we are going to see about host. A host is one or more networked computers that have been set up to handle each user visiting or requesting information. A host is responsible for many different responsibilities. For example, a host may be responsible for handling each of the computer players in an online game or for sending users a web page on the internet. Each computer connected to the host computer is known as a client. Workstation. In this video, we are going to see about workstation. 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 A high-performance computer system that is basically designed for a single user and has advanced graphics capabilities, large storage capacity, and a powerful microprocessor that is central processing unit. A workstation is a name given to a single computer that is connected to other computer or network. Bandwidth. In this video, we are going to see about bandwidth. The amount of information that can be transmitted through a communication channel in a given amount of time, that is the capacity of the channel. It is often uttered in bits per second or alternatively bytes per second, leading to lots of confusion. Bandwidth figures are used to express the capacity of a network link or interface, for example, a 100 Mbps Ethernet interface, or the rate of information transfer, for example, a file downloading at 3.2 KB per second. When referring to user's own connection, bandwidth, communication speed, or connection speed is the total maximum capacity of the network or modem connection. The more bandwidth a computer has, the faster it will be able to receive and send information. A modem with a connection of 56 kbps is nearly twice as fast as 128.8 kbps, and users with a broadband connection can transfer speeds of several MB every second, which is more than triple the speed of the fastest modem. Interoperability. Now we are going to see about the process of interoperability. Interoperability is the ability of different networks or programs to work or communicate together without the need of additional tools or interfaces required by the user. For example, most networks use TCP/IP, which is available on all operating systems, computers, and supported with most networks. In this current internet age, it is important that networks of different type are able to communicate with other types of network. Not being able to transfer data between networks may isolate a network and decrease efficiency. Network administrator. Now let us see the process of network administrator. A network administrator is an individual or group of individuals responsible for the maintenance and operation of a network or server. A network administrator may be responsible for maintaining a network and may be assigned to one or more of the below tasks. Network administrator responsibilities: allocating and adding disk storage space, designing or redesigning the network, expanding the network, helping employees with computer questions, installing and upgrading computers and network equipment on the network, managing filters and rules, for example ACLs, firewalls, QoS, spam filters, monitoring the network, resetting usernames and passwords, setting up a network device or computers on the network, testing a network for security vulnerabilities. Examples of network administrator certifications: MCSA, Network Plus, CCNP, CNA, RHCE. Network security. In this video, we are going to see about network security. Network security, a specialized field in computer networking that involves securing a computer network infrastructure. Network security is typically handled by a network administrator or system administrator who implements the security policy, network software and hardware needed to protect a network, and the resources accessed through the network from unauthorized access, and also ensures employees to have adequate access to the network and resources to work. A network security system typically relies on layers of protection and consists of multiple components, including networking monitoring and security software in addition to hardware and appliances. All components work together to increase the overall security of the computer network. Server. In this video, we are going to see about server. Server is a main computer that provides services to other computers which holds stored files, programs, and network operating system. This is the administrator that controls functioning of other computers and responsible for the division of labor among computers in a shared network. Client. In this video, we are going to see about client. Any computer that is a part of a common network other than the server is called client. It is less powerful than server computer. The client computer accesses network and shared resources provided by the server. Communication media. In this video, we are going to learn about communication media. Transmission media interconnects the computers in a network. Transmission media may be wired or wireless, wired or bounded, coaxial cable, twisted pair wire, fiber optic cable, wireless or unbounded, Wi-Fi, Bluetooth. Peer-to-peer network. In this animation, we are going to see peer-to-peer network. In peer-to-peer networking, there are no dedicated servers or hierarchy among the computers. Normally, each computer serves as client server and there is no one assigned to be an administrator responsible for the entire network. All of the computers are equal and therefore known as peers. Peer-to-peer networks are good choices for needs of small organizations where the users are allocated in the same general area, security is not an issue, and the organization and the network will have limited growth within the foreseeable future. Advantages: easy and simple to set up, only requiring a hub or a switch to connect all computers together. You can access any file on the computer as long as it is set to a shared folder. If one computer fails to work, all the other computers connected to it still continue to work. Disadvantages: security is not good, other than setting passwords for files that you don't want people to access. If the connections are not connected to the computers properly, then there can be problems in accessing certain files. It does not run efficient if you have many computers, so it is best to use 2 to 8 computers. Client-server network. In this video, we are going to learn about client-server network. The term client-server refers to the concept of sharing the work involved in processing data between the client computer and the most powerful server computer. A server is a computer running a process that provides a service to other computers when they request it. A client is a computer running a program that requests the service from the server. Client-server networks are more suitable for larger networks. A central computer or server acts as the storage location for files and applications shared on the network. The server also controls the network access of the other computers, which are referred to as the client computers. For example, a LAN-based database application stores its data on a server which stands by waiting for clients to request information from it. Users of workstation computers run a database client program in which they generate queries that request specific information in the database and transmit those queries to the server. The server responds to the queries with the requested information and transmits it to the workstations, which format it for display to the users. They are also responsible for taking the raw data from the server and displaying it in a comprehensible form to user. Advantages of client server: all files are stored in a central location. Backups and network security is controlled. Users can easily access to the shared data. Disadvantages of client server: a special network operating system is needed. The server is expensive to purchase and difficult to set up initially. If one of the server goes down, all the users get affected and it may even bring the whole network down. Domain Name System (DNS). Now we are going to see about Domain Name System (DNS) in this video. The Domain Name System (DNS) was originally invented to support the growth of email communications on the ARPANET and now supports the Internet on a global scale. The DNS as a whole consists of a network of servers that maps Internet domain names like www.livinginternet.com to a local IP addresses. The DNS enables domain names to stay constant while the underlying network topology and IP addresses change. This provides stability at the application level while enabling network applications to find and communicate with each other using the Internet protocol, no matter how the underlying physical network changes. DNS uses a client-server network architecture. The Domain Name System (DNS) servers distribute the job of mapping domain names to IP addresses among servers allocated to each domain. Domain name and their organization. Now let us see the process of domain name and their organization. Internet domain names are the alphanumeric identifiers people use to refer to hosts on the Internet like livinginternet.com. The structure of Internet domain names was first described in RFC 819 and their syntax was first described in RFC 822. Domain names come in four main types as follows: top-level domains, second-level domains, third-level domains, country domains. Top-level domains. Internet domain names are organized by their levels, with the higher levels on the right. Every domain name ends with a top-level domain label. For example, for the domain www.20.net, the top-level domain is net. Some of the top-level domains are .gov for government sites, .edu for educational institutions, .org for organizations that is non-profit, .mil for military sites, .com for commercial business, .net for network organizations. Second-level domains. Top-level Internet domains like .com are shared by all the organizations in the domain. Second-level domain names like yahoo.com and livinginternet.com are registered by individuals and organizations. Second-level domains are the addresses commonly used to host internet applications like hosting and email addressing. Excluding the top-level domain portion, second-level domain names can have up to 61 characters. For many years, characters were restricted to the 26 letters, 10 numbers, or the hyphen character, except the hyphen can't be the first or last character. Third-level domains. Third-level domain names are created by those that own second-level domains. Third-level domains can be used to set up individual domains for specific purposes, such as a domain for web access and one for mail, or a separate site for a special purpose like www.livinginternet.com, mail.livinginternet.com, rareorchids.livinginternet.com. Fourth level and even higher internet domains like www.2.un.news.media.20.net can also be established. 3 of these 4 levels is usually sufficient for most purposes. Country domains. Each country in the world has its own top-level internet domain with a unique alphabetic designation. A few country domains are shown below. .in for India, .au for Australia, .ca for Canada, .us for United States. Understanding the Internet Protocol Address. In this video, we are going to see about understanding the Internet Protocol Address. Internet Protocol, that is IP address, is shortly called as IP address. An IP address is an identifier for a computer or device on a TCP/IP network. Networks using the TCP/IP protocol route messages based on the IP address of the destination. What is my IP address? To launch the command prompt from a Windows-based computer, click on Start, points to All Programs, points to Accessories, points to Command Prompt, and type ipconfig and hit Enter. ipconfig displays all current TCP/IP network configuration values and refreshes Dynamic Host Configuration Protocol DHCP and Domain Name System DNS settings. User can also use Google search to find the IP address. Type "What is my IP address" in the search box and Google will show the IP address of the computer from which the query was received as top search result. The format of an IP address. The format of an IP address is a 32-bit numeric address written as 4 numbers separated by periods. Each number can be 0 to 255, for example, 1.160.10.240 could be an IP address. The 4 members in an IP address are used in different ways to identify a particular network and a host on that network. Within a remote network, user can assign IP addresses at random as long as each one is unique. However, connecting a private network to the internet requires the use of registered IP addresses called internet addresses to avoid duplicates. An IP address can be static or dynamic. A static IP address will never change and it is a permanent internet address. A dynamic IP address is a temporary address that is assigned each time a computer or device accesses the internet. Bus topology. In this video, we are going to learn about bus topology. Bus topology, also called horizontal topology. In bus topology, multiple devices are connected one by means of a single cable. Bus is passive topology because it requires termination. The central cable is the backbone of this network and is known as a bus. When one computer sends a signal up the wire, All the computers on the network receive the information, but only one accepts the information, the rest discard the messages. Advantages: easy to use and easy to install. Needs fewer physical connectivity devices. A repeater can also be used to extend a bus topology network. Low cost. Disadvantages: heavy network traffic can slow a bus considerably. It is difficult to troubleshoot a bus. Failure of a cable affects all devices on the network. Difficult to add new node. Star topology. In this video, we are going to learn about star topology. A star topology consists of a number of devices connected by point-to-point links into a central hub. In star topology, every node, that is computer workstation or any other peripheral, is connected to a central node called a hub or switch. A star network consists of one central switch, hub or router, which acts as a conduit to transmit messages. All peripheral nodes may thus communicate with all others by transmitting to and receiving from the central node only. Advantages: it is easy to modify and add new nodes to a star network without disturbing the rest of the network. Centralization allows the inspection of traffic through the network. Easy to detect faults and to remove parts. Installation and configuration is easy. Failures of any node do not bring down the whole star network. Disadvantages: if the central hub fails, the whole network fails to operate. Each device requires its own cable segment. Requires a large amount of cable to be connected. Token ring topology. In this video, we are going to learn about token ring topology. In a ring topology, each computer is connected to the next computer with the last one connected to the first. Data travel from node to node, with each node along the way handling every packet. The signals travel on the cable in only one direction. Each computer retransmits what it receives. Because a ring topology provides only one pathway between any two nodes, ring networks may be disrupted by the failure of a single link. Ring is an active network. In this, termination is not required. Advantages: cable failures are easily found. Performs better than a bus topology under heavy network load. Does not require a central node to manage the connectivity between the computers. It is quite easy to install and reconfigure, since adding or removing a device requires moving just two connections. Disadvantages: adding or removing nodes disrupts the network. It is difficult to troubleshoot a ring network. Failure of one node on the ring can affect the whole network. Cost of cable is more in ring network. Ethernet. In this video, we are going to learn about Ethernet. Ethernet is a physical and data link layer technology for local area network (LANs). Ethernet was invented by engineer Robert Metcalfe. When first widely deployed in the 1980s, Ethernet supported a maximum theoretical data rate of 10 megabits per second (Mbps). Later, fast Ethernet standards increased this maximum data rate to 100 Mbps. The run length of individual Ethernet cables is limited to roughly 100 meters, but Ethernet networks can be easily extended to link entire schools or office buildings using network bridge devices. Ethernet port. An Ethernet port is an opening on computer network equipment that Ethernet cables plug into. These ports are alternatively called jacks or sockets. Ethernet ports accept cables with RJ45 connectors. Ethernet card. An Ethernet card is one kind of network adapter. These adapters support the Ethernet standard for high-speed network connections via cables. Ethernet cards are sometimes known as Network Interface Card, that is NICs. FDDI. In this video, we are going to learn about FDDI. FDDI. FDDI, Fiber Distributed Data Interface, is a set of ANSI and ISO standards for data transmission on fiber optic lines in a local area network (LAN) that can extend in range up to 200 km, that is 124 miles. The FDDI protocol is based on the Token Ring Protocol. In addition to being large geographically, an FDDI local area network can support thousands of users. FDDI is frequently used on the backbone for a wide area network WAN. Features of FDDI: number of stations, up to 1000 connections are allowed, 500 and connected stations. Total fiber path, up to 200 km of total fiber length is allowed. Typical parameters of transmission medium are: optical source 1300 nm LED, core diameter 62.5 micron, cladding diameter 125 micron, numerical aperture 0.275, bandwidth 500 MHz per kilometer. Advantages: high bandwidth, security, use of multiple tokens, system fault tolerance. Disadvantages: FDDI is a complex technology. FDDI is costly. Asynchronous Transfer Mode (ATM). We are going to see about Asynchronous Transfer Mode (ATM) in this video. Asynchronous Transfer Mode (ATM) is a streamlined packet transfer interface. ATM also is a connection-oriented network. ATM uses packets of fixed size for communication of data. These packets are called as ATM cells. ATM is used for efficient data transfer over high-speed data networks. ATNI provides real-time and non-real-time services. The services provided are synchronous TDM streams such as T1, services using the constant bit rates, compressed voice and video, traffic with specific quality requirement using the non-real-time variable bit rate, IP-based services using available bitrate ABR and unspecified bitrate UBR services. The ATM needs an adaptation layer for supporting the information transfer protocols that are not based on ATM. Cell relay. ATM is also known as cell relay. It has advantages of better reliability and fidelity, which allows faster packet switching than X.25. Applications. ATM was developed as a part of work on ISDN. But now it is used in non-ISDN system where the data rates are very high. ATM protocol architecture, that is ATM reference model. ATM is a streamlined protocol. It has minimal error and flow control capabilities. Hence, the number of overhead bits required with each cell is reduced, which enables ATM to operate at high data rates. Also, due to the ATM cells of fixed size, the processing required at each node is simplified. This also supports the use of ATM at high data rates. ATM protocol architecture for an interface between user and network. Layers in the ATM protocol model are physical layer, ATM layer, ATM adaptation layer, that is AAL, physical layer. The physical layer of the protocol involves the specification of a transmission medium and encoding scheme. The data rates specified at this layer are between 25.6 Mbps and 622.08 Mbps, but data rates higher and lower than these are possible. ATM layer. This layer is common to all the services that provide the packet transfer capabilities. This layer defines the transmission of data in fixed size cells, and it also defines the use of logical connections. ATM adaptation layer, AAL. This layer is a service-dependent layer. It is used for supporting the information transfer protocol not based on ATM. The AAL maps the higher layer information onto the ATM cell, and cell is transported over the ATM network. Planes in the ATM protocol model are user plane, control plane, management plane. User plane. It is used for transferring user information along with associated control. Control plane. It is supported to perform the call control and connection control functions. Management plane. It includes the plane management. The management plane performs management functions related to a system. They include provision of coordination between all planes, layer management, management function relating to resources and parameters residing in its protocol entities. Intranet. In this video, we are going to learn about intranet. Intranet, intranet, extranet, and the internet are all networks of network. Intra means internal or within plus network. The major difference between the three classes of network is the aspect of network traffic control, that is, who are the participants in the network. Intranets are owned by individual organizations, that is, intra-enterprise systems. Some organizations operate their own network and some outsource that function to network operations groups, example, EDS, AT&T Data Solutions, etc. A key characteristic of intranet implementation is that protected applications are not visible to the internet at large. Intranet access control relies heavily on the physical access point to the corporate LAN. Secure intranets are separated from the internet by means of a firewall system. Inbound internet traffic is not allowed into the corporate security perimeter except for email. Outbound network traffic destined to the internet from the intranet is not usually filtered. Some corporations constrain outbound traffic to allow only web-based protocols, example, HTTP, FTP, and IIOP. Some of the difference between an intranet and internet are the quality of service QoS or lack of service level agreements SLAs, which describes availability, bandwidth, latency, and response time. Most internet service providers, ISPs, and networking device vendors are developing an internet level of service capability.